Chapter. Chapter name is chapter name is LLM, Newton's law of motion. We will explore in too much details. We will dive into too much details. Let's start from basic. First is Newton's first law. First is Newton's first law. It explains that anybody which is in a rest will be in a rest. Anybody which is in motion will be moving. Okay, will be moving. But external force, there will be no external force. No. External force will be zero. Okay, this is the definition of Newton's first law. Not a definition, but it is the first law of Newton. Okay. Main thing is force. Force is a factor which will change the state of motion of moving object, the state of object which is in rest. Who will change? It is all about force. Okay. So here, force is what? Force, it is just a push or pull. If we push something, it means this is force. With how much Newton you are pushing the object, with how much Newton you are pulling the object. It's all what force. Yeah, there are types of force we will see later. But right now, just understand this force is just a push or pull. Just push or pull. Now next, unit will be MKS. N means our unit for force is known as Newton. Next, gravitational unit is gravitational unit. Gravitational unit is known as, this is known as kgWt. kgWt. First is unit which is in MKS, and second is a gravitational unit which is a kgWt. Now next thing is here we are already familiar. It's not a new for us. Next is the effect of resultant. Effect of resultant force. Resultant force means third force. Resulting force. Whatever we applied force, so what is coming as a result will be known as a resultant. So effects of a resultant force will be what? We know that it can change shape of a body when we apply. So body should be flexible, not solid. Then we can change the shape of a body by applying force. By applying force, moving object which velocity is constant can be accelerated by applying a force. Yeah. Moving object can be stopped again through force. All these things can happen when it comes to force. Okay. One more. We can increase the speed of moving object. We can decrease the speed of moving object. It can happen. Decreasing and increasing of object can happen by the help of force. These are effects of force. These are effects of force. So next we have inertia. Inertia is also known as this is first law of inertia. It can be whatever you saw about Newton's first law is also for inertia. There are three parts of inertia: inertia of rest, inertia of motion, inertia of direction. Just understand that now inertia, it is saying that if object is external force, for inertia external force is zero. If a object is in a rest, again that object will be in a rest. Inertia, that object when that object will come into rest, that part will be known as inertia. And details we will talk about in this part. Right now, just to understand, this is directly proportional to inertia is directly proportional to mass of the body. Means if a mass is more, let's say there are two boxes like this. There are how much? Two boxes. Now tell me which one will take a less force. You would say this first A. If you want to bring this first object into motion, of course we will apply less force as compared to force for this B object. But when it comes to this second, over here our force will be more, and over here our force will be less. It is all about what is the weight of mass. Okay, what is the mass of the body? If here you can see inertia. So if force is more, inertia will be more. If a force is less, inertia will be less. Clear? How will we measure? By looking at the mass. Here easily we can see. Here mass of this object is less and mass of this object is more. That's why here inertia will be less, here inertia will be more. Here force will be less, here force will be more. Okay. This is the meaning of inertia is directly proportional to mass of the body. Now next point, you can this was in sentence. We can convert it into mathematical language, which is inertia is a directly. This is a symbol of a directly proportional mass. It means if a mass of the body is increasing, then inertia will also increase. This is meaning of a directly proportional. Okay, if mass of the body is decreasing, then inertia will decrease. Next, as I told you, there are three parts of inertia. First, we are starting from inertia of rest. From inertia of rest. From what you can understand, what is it saying? It is saying, this is saying, object is already in a rest. Object is already in a rest. When we will apply force, how much force is required for that object so that object can come into motion. That will be known as inertia of rest. Object is already in a rest until and unless external force is applied. Okay. So for this inertia of rest, it is inability of the body to change its state of rest by itself. For example, for instance, when a bus starts, when a bus starts, what? When a bus starts suddenly, the passengers tends to fall backward. Backward means if a passenger is like this, then that passenger will go backward in this direction. When bus will be started, okay? When bus will be started, it happens because of already person was in a rest. Person was in a rest. When external force came into picture, then that passenger went backward. It's all about this phenomena is known as inertia of rest. If object is already in a rest and external force will be applied, then that object will come into motion. Okay, this was an example for inertia of rest. Now next we have inertia of motion. Inertia of motion. Inertia of motion. Look, here our acceleration will be zero. Acceleration will be zero. If you object is moving, okay, object is moving with constant velocity. With constant velocity. Either we can change, either we can decrease the speed of a moving object, or increase. Yeah, it's your choice. If object is coming, and we wanted to stop that object which is coming. So what will we do? Of course, we will apply force like this. We will push that object which is coming. Yeah. What is happening over here? Phenomena is the object is in motion and that wants into motion, but we applied external force. When we will apply external force, then that object, state of moving object will change, and change will what? That object will come into rest. Another thing can happen, which is decreasing or increasing of speed of the object. We can increase by applying force. What we can increase the speed of moving object by applying force on a moving object. On the other side, you can also decrease the speed of a moving object by applying force. What is happening? Main thing is what? Acceleration is zero. Acceleration is zero. Velocity is constant. Then we will say that yes, object is moving. Object is moving with a constant velocity, and that object wants doing motion. Clear? Here have an example. Same example when we were discussing about inertia of rest. Example was what? When a bus starts suddenly, then a passenger goes backward, but here forward. When bus will stop, when driver will stop a bus suddenly, then what happens? Passenger comes inside forward like that. It happens because of vehicle was already in motion. Okay, when external force, which is brake, was applied by the driver, then passenger came into again. I think a vehicle came into rest. Already vehicle was in motion. Okay, it happened because of inertia of motion. Inertia of motion. That object was moving and that wants to move. Next we have inertia of direction. Inertia of direction. Inertia of direction means if direction is given, there is a one direction. Let's say this right straight direction. object will be going into straight direction. When we will take turn, what will happen? Of course, we will apply brake, then accelerator. All these things will be done just to take turn. It means we applied external force when it comes to brake or accelerator. If you go with the same velocity when you were over here, then here your control, you will not have control. I am saying when direction is the same, so that object wants in same direction. But when it comes to different direction, then in that case we will have to apply force so that we can change our direction. If direction is a circular, in that case this is our circular direction. Object will be moving in circular direction. If you want after one round that object should go in this direction, so here direction will be different. For this direction we will have to apply force so that object can come into this direction. Okay, it will happen. This phenomena is known as the inertia of a direction, and object will come into this direction when external force will be applied. Okay, this was about inertia of a direction. Now next we have momentum. 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 Momentum means it will tell you, it will provide the amount of motion, the amount of direction, amount of mass and velocity, magnitude and direction, amount of magnitude and direction will be our momentum. Okay, so definition is, it is a product of mass multiple velocity. When we take mass multiple velocity, we get a momentum. Momentum means what is the amount of motion of the object and in which direction that object is moving. At the same time, we will see what is the mass of the object. For example, this is object and this is object. You can see this is a 10 kg and it's a 20 kg. You know. Now let's say velocity is constant. Velocity is 5 meter per second. What do you think? What will happen when velocity is 5 meter per second for both objects? Here, this object will move slowly as compared to A object. Why? Reason is, here object mass of this object is less as compared to B. That's why this will move faster than B object. Another reason is velocity is the same for both, but mass is different. In that case, what is happening? A object will be moving more, it will be covering more distance, but when it comes to B object, this will be covering lesser distance. Okay, so we found this lesser distance, more distance because of how when we took mass of the object and then velocity. Here you can see momentum for this object will be 15 and momentum for this will be 100 and 50. So here 50 is less. It means momentum is more. I think it will be, yeah, momentum is less. Over here momentum is more. 100. Momentum is more. Just understand it is the amount of magnitude and direction. Direction. In the language of mathematics, it can be written as P. P is a letter which is represented as a momentum. So P will be equal to, for M we have M, for mass we have M, and for velocity we have V. V is a vector. So here mass multiple, but mass is not vector. Mass is not vector. Okay, so momentum, remember momentum is a vector quantity. Okay, momentum is a vector quantity. Our formula is P. P is equal to mv. From this equation, we are crystal clear about the definition of momentum. It is the product of mass and velocity. This momentum is directly proportional to mass into velocity. Clear? Whatever will be direction of P will be also, for example, direction of V now. So momentum or direction, that direction will be also for momentum. Direction will be set for momentum and velocity. For velocity. Momentum of a system of a particle or body. Next thing is momentum of a system of a particle so P system will be equal to P1 plus P2 plus P3 till the Pn. Means just we will add all the momentum. For example, we are taking momentum of a particle, momentum of a system of a particle. There is a system, and inside this system there would be a lot of particles. So these are momentum of those particles. This is a momentum of one particle. This is a momentum of another particle. Like this, whatever will be number of particle you will have, just add. Okay, just add all those momentums. You will get P system, means whole system. Whole, we are taking whole, not only one part. Okay, this P1 will be one part, but when it comes to P system, we are taking all these parts, all these particles, momentum of all the particles. Just you will add when it comes to a lot of particles. From here we can understand one thing more, which is relation between kinetic energy and magnitude of momentum. That one. Relation between kinetic energy. What is the relation between the kinetic energy and momentum? Magnitude of momentum. It is talking about only magnitude of momentum without having direction. So you will say A is directly proportional to momentum. P square upon 2A. Only for a body. body system. This will be valid for only body system. Here try to understand how did it come. How did it come? You know K is equal to half mv square. Half mv square. If you multiply m in numerator as well as in numerator, then what will happen? It will become 1 by 2 m square v square upon m. Here we have this mv square. This will become p square upon m. The same thing here, p square upon 2m. K is equal to. That is how this equation came. We brought this equation from basic kinetic energy. K is known as kinetic energy is known as 1 by 2 half mv square. Okay, so remember this is the relation between them. Momentum is directly proportional to kinetic energy. 1 by v and 1 by m. M is a mass. M is a mass. Now let's see important points. Important points. Important points. First important point is, if momentum of a system is zero, if a momentum of this system is zero, then kinetic energy of a system may not be zero, may be zero. Okay. If P is equal to zero, but when it comes to kinetic energy, this can be, maybe zero, not maybe zero, maybe zero. If a momentum is zero, don't think momentum is zero, it means the kinetic will be zero. Now this is an important point. For example, let's understand it by figure. Let's understand this by figure. Figure is this one object, one particle, and this another particle in a body. Mass is also same and velocity is also same. Mass of the body, this is one particle, this is another particle. Both mass, its masses are equal, as well as velocity as well. This is complete a system or body. It says T system will be our this 1 plus 1, but direction is opposite. For direction opposite, we take minus. So T system will be our this first P1 minus P2. Why minus? Because of direction. Masses are same. Here we can say this is coming mb minus mb will be 0. But when it comes to kinetic energy system, we now 1 MPa square plus 1 by 2 MPa square. Why? Reason is kinetic energy don't care about negative sign, okay, negative sign, because it does not provide a direction, because kinetic energy does not provide direction. This was the usual difference between them. Okay, so here simply we can say this kinetic system for this figure will not be equal to 0. This can be said. Okay, this can be said. Here base of momentum is becoming 0 for this same figure, but when it comes to kinetic energy, then it is not becoming equal. This was this was a first fact. Okay, next figure, another same figure. Here same figure I am drawing over here. This is one object, this is another object. V is equal to 0, V is equal to 0. Masses are same. Again, this is a system. Main point I will highlight more during this lecture. Main points. So P system for this figure, P system will be our what? 0. But kinetic energy will be also 0. Kinetic system will be also 0. Reason is this V is 0. Reason is V is 0. When you will put this V as 0 in this, so this one term will become 0. This second term will become again 0. So finally we will get 0. Here both became 0. Reason was velocity is 0. Okay. If mass will be 0, then again same answer will come. If velocity is either velocity or mass is coming as a 0, then answer result would be 0. P system will be 0, kinetic energy system will be 0. Clear? Now next point. Next is secant. If kinetic energy of a system is 0, then momentum of a system must be 0. It will happen, must be 0. If a kinetic energy of a system is 0, it means if K system is 0, then momentum of the system must be 0. Again, must be 0. Just opposite. Whatever we saw in the previous, we saw that momentum was coming as a 0. Right now, kinetic energy is coming as 0. So remember, if a kinetic energy is coming 0, so momentum will be 0. But if a momentum is coming 0, it doesn't mean kinetic energy will be also 0. No. Kinetic energy may be 0, may not be 0. Okay. But firstly, kinetic system is coming as 0, then you have to be sure that momentum will be 0. Momentum will be 0. So finally you can say percent change in y. There is a formula. complete y upon y1 multiple 100, or you can write this as a so this complete total y can be written as a y2 minus y1 upon y1 into 100. Complete y 100% change in y, we will write complete y upon y1 initial y, and this we know that it can be written delta y can be written as y2 minus y1 upon y1 into 100. 100 came because of we are finding percentage change in y in variable. This formula will be used, just delta p upon y1, delta y upon y1. I think no. Now next point is if y is directly proportional, AP, BP, BQ upon CR, and the percentage change is equal to or greater to 5%, then 100% change in y will be our 100% change in y will be our just formula. We will use formula delta y upon y1 into 100 into 100. Here delta a upon a multiple 100 plus q, we will write this like this: p then delta a upon a multiple 100 then q. If equation is like this, then p delta a upon a, then multiple 100 plus delta b upon b multiple 100 like this. Okay, multiple 100 delta b upon b multiple 100. Finally, we wrote this two which were present in numerator. What about the denominator? For denominator, we will use the minus because it is in denominator. Minus this is r in the square. This is r delta c upon c multiple 100. That is how we will write when it comes to like this equation. So y is directly proportional to AP into BQ upon CR. Nothing is so difficult in this case. Just we will convert this into this form: P multiple this upward P multiple a delta a upon a, then multiple 100 plus this q into delta b upon b multiple 100, then minus 4 division. So r this square r into delta c upon c multiple 100. Just we converted this into this form so that we can calculate whatever question is asking. Let's take a question. Let's take question. Let's take question. If momentum will increase by 0.3% and the mass will decrease by 0.2%. Then find out percentage change in kinetic energy. Kinetic energy. Question is in front of you. Read this question. If momentum will increase by this much percentage, and mass will decrease by 0.2%, then found out here momentum is increasing, but mass is decreasing. Then found out percentage change in kinetic energy. How much percentage change is in kinetic energy? We already know what kinetic is. We know. Let's solve together. Kinetic is directly proportional to p square upon m. P square upon m. And we saw how to convert this thing into another form. Just you can write delta k upon k multiple 100. This can be written as delta k upon k multiple 100. Multiple 100. Now let's convert this form into another form. This will become 2 delta p upon p. Reason is this 2 will come downward, and this complete p upon p1. Okay, upon p1. This is the reason. Just we wrote this. Just we convert this k into this form. Delta k upon k into 100. And now we are going to convert this into this form, which will be, but our focus will be on this thing, p square upon m. 2 will come downward and complete delta p upon this p1. Plus. For m we will take minus. So plus, not plus but into 100. Now it's a time for this m minus m. But complete delta m upon m multiple 100. That is how we will write delta m upon m multiple 100. Now it's a time to solve it. This delta k upon k, we are finding change in kinetic energy from kinetic multiple 100. How much? Initial kinetic energy was how much, and total kinetic was in this total kinetic energy is how much it change into percentage. This 100 is a 4%. Momentum over here p is 0.3%, and m is how much in percentage? 0.2%. Okay, 0.2%. So can you write 2 multiple how much? 2 multiple 0.3. 2 multiple 0.3. 0.3 multiple 100 upon 0.3. 0.3. Okay. Then minus m is almost 0.2. This is our, that is how we will write So this is this much, 0.2 minus 0.2, decrease minus 0.2 minus 0.2. So finally our answer is 0.8%. This much percent change is in kinetic energy. This much percent. Where momentum was given, mass was given, and just we know it is asking kinetic energy. So kinetic energy is directly proportional to P square upon delta K upon K into 100, and just our focus will be over here. So this 2 will come downward to delta P upon P multiple 100 minus delta M upon M multiple 100. Okay, that is how we will simplify it. At the end we will get this much answer, which is 0.8%. It is saying that this is a change, this percent is a change in kinetic energy, where momentum is 0.3 and mass is decreasing with a percentage of 0.2 in this case. Okay, now next point is fourth point is change in momentum. Try to understand. We now complete momentum will be delta. This is complete, but it is asking what is the change in this complete momentum. We will write final momentum minus initial momentum. This complete means final minus initial. We will get complete momentum. So final PF minus P initial. Here you are understanding that this delta P vector can be written as vector P final minus vector P initial, where mass is a constant. But remember, this is valid when mass is constant. This will be valid when mass will be constant. Clear? Now next, you know that delta P can be written as M into BF minus here just we are multiplying this M by this. So final velocity minus initial velocity is our complete velocity. This is equal to MB is equal to M. This can be written as your complete velocity, delta B. Here mass is constant. Okay, mass is constant, but it is asking change in momentum. So finally, of course, we will take this final velocity minus initial velocity because of change in momentum. When it comes to change, we start initial final velocity like this. But remember, this is an initial momentum, final momentum, M into B. But this is total. This is a total velocity, delta B, total velocity. Okay. Just here we added M, and we know this is the value of delta P. We added. If you want to simplify this further, you can simplify just putting value of P as MB. Now next question. by 150%, having constant mass. Then find out percentage change in kinetic energy. Let's assume again it is asking what is the change in kinetic energy in the form of a percentage, where momentum will decrease by 150%, having constant mass. Momentum is increasing by this much percentage, where mass is constant. Here, kinetic energy is equal to 1 by 2, but P square upon 2a. This came from here. K is directly proportional to P square upon m. K is directly proportional, but K is inversely proportional to 1 upon B. And K is directly proportional to P square. But K is inversely proportional to 1 by 2a. It is 1 by 2. Here you can write kinetic energy is directly proportional to 2.5 raised to power 2. 6.5 times. Percentage change in momentum will be equal to PF minus PI upon P1 multiple 100. This is our formula. Percentage change in momentum, this is our formula, PF minus P1, P initial upon P1, P initial. So final momentum is 6.25. Here final momentum is 6.25 and initial is 1 upon 1 multiple 100. This will become this much, whereas it is how much? 525%. P1 is initial momentum is 1, final momentum is 6.5 times. 6.5 times. 2.5. Where is it? 2.5. Now next point. Next is second law. Second law. When it comes to second law, you are familiar with this equation F is equal to m. But my question is, how did it come? How did it come? This is not the exact second law of motion. F is equal to m. Okay, this is not exact. First of all, try to understand what is the second law of motion. It says that with how much force, external force was how much? Okay, external force was applied how much on object. By the help of second law of motion, we calculate amount of force. So let me write it complete. This law defines that the rate of change of momentum of a system is directly proportional. Proportional to the applied external force. Just understand what is the rate of a change of momentum of this system. Whatever will be change of momentum of this system will be directly proportional to the applied external force. Means whatever we applied external force, this is external force. So this will be our directly proportional. F will be, which is external force, will be directly proportional to momentum. Okay, momentum. So momentum, this momentum, F is equal to P. Okay, F is equal to P. But in the language of a vector, we write it as like this. A vector F is equal to dp upon dt. Remember, momentum will happen with respect to time, dp upon dt. This is our exact definition, exact equation of a second law. F is equal to dp upon dt. From this equation, we will get F is equal to m. From this equation. Okay. So tell me, what is the formula for momentum? You would say mb, where b is a vector, dt. This can be written as just we substituted value of a momentum, and here our mass, if mass is a constant, there are two variables, m and b. So it's a time to differentiate it. So m will be outside, and we will differentiate this v, dv upon dt. Then plus it is a multiplication. Now we will be outside. Okay, we will be outside. dm upon dt. M is not vector. Okay. So how did it come? It came just in this case. Just we substituted value of momentum, and in this case, just we did differentiate it. That's it. This first was outside, and second was differentiated, and then second velocity became outside. This was outside, and then we differentiate m. Now case number one. If m is a constant, remember, if m is a constant, It means depreciation of a constant will become 0. So this will become 0, this whole term will become 0. But over here, m is, we are not saying m is 0. Okay, m can be any number, but depreciation of any number, only number will be 0 always. Over here, if m is 0, this again this 1 will become 0. But m is 1, then our formula will be only dv upon dt. 1 is a constant. So then dm upon dt, this, it is talking about this, dm dt will become 0. Reason is the depreciation of a constant is known as 0. This is reason, main reason. Okay, so simple formula will become only this thing we will bring over here, m dv upon dt. This term became 0. This formula we will apply when m is constant, mass is constant. Okay, next, second, when velocity is constant. If velocity is a constant, in that case what will happen? This term will become 0, and this second term will exist. So dv upon dt will become 0.